Okay, the section 3, we introduce the entropy based on Carnot cycle. We know Carnot cycle is very important in thermodynamics. From the Carnot cycle, we can obtain QH divide TH plus QL divide TL. Just as Q over T sigma is 0. From the Carnot theorem, very easy to obtain this equation. Carnot cycle consists of two adiabatic lines and two isothermal lines. Heat transfer only happens in isothermal processes. Therefore, for any cycle, we can do some analysis about the Carnot cycle. Like this. Carnot cycle we know is two adiabatic lines and two isothermal lines. For any reversible cycle, for example, in PV diagram, we have a cycle, reversible cycle. 1A2, 2B1 construct a cycle. It is any cycle. It can be separated by innumerable reversible adiabatic lines to make many small Carnot cycles. We use the adiabatic line cut this reversible cycle. We can obtain many small Carnot cycles. For any Carnot cycle, for example, small a, B, C, D, A, this small cycle, we can obtain equation like this: QH over TH plus QL over TL equals sigma Q over T equals 0. Because this small Carnot cycle is reversible, so very easy to obtain this equation from the Carnot theorem. Count up whole small cycle, we can obtain these very long equations. The first term, dQH over TH plus dQL over TL, is the first small Carnot cycle. The second small Carnot cycle is dQH prime over T prime H plus dQL prime over T prime L. Here is second small Carnot cycle. The third one, fourth one, many small Carnot cycle together. We can find the dQL prime, dQH 2 primes, dQH prime, dQH 2 primes. The high temperature, we can together them, dQH over TH plus dQH prime over TH prime and dQH 2 primes over TH 2 primes together. And the low temperature, dQL over TL, dQL prime over TL prime plus dQL 2 primes over TL 2 primes together, plus together, sum of them together also is 0, because any small Carnot cycle is reversible. From here, we can obtain the integration 1A2 integration dQ over T high temperature plus integration 2B1 dQ over T express the low temperature. Together, them is 0. Hence, this equation becomes integration, the cycle integration dq over t is 0. From this equation, we can obtain also this equation indicates dq over t has no relationship with the path of the integration. It will be sure dq over t is a property. Here, with supposing ds equals dq over t, finally we obtain a new concept as we can give a name to as is entropy. So entropy in reversible process is ds equals dq Re over t. Here Re means reversible process. Entropy, here the entropy unit is kilojoules per Kelvin. Sometimes we use joule per Kelvin. The subscript Re means reversible process. For unit mass, the specific entropy is d small s equals delta q small q Re over t. When system undergoes a change of a state, the entropy change is delta S is S2 minus S1 equals from 1 to 2 integration delta Q Re over T. Please notice Re means reversible process. Okay, we give some discussion about that. 1. Entropy change in reversible processes. Entropy is a property of a system. Please remember, always remember property. S is a property, or to say entropy is a state parameter, only relation to the state. Okay, so the cycle integration just is delta Q over T always is 0 for reversible process. In reversible process, delta S is S2 minus S1 is equals from 1 to 2 integration delta Q over T. So for differential equation is T ds equals delta Q. The first and second TDS equation. At this point, we derive two important thermodynamic relations from TDS equals delta Q. From the first law, we have dq equals du plus pdv. If we use TDS to express delta Q, so we obtain another equation is TDS equals du plus pdv. This equation, we can call it the first TDS equation. Also, we know that enthalpy is defined as H equals U plus PV. U is internal energy, P is pressure, V is volume, PdV. It follows that dH equals du plus PdV and VdP. So, because last page tells us du and PdV just is TDS, so dH just is TDS and VdP. Finally, we obtained TDS equals dH minus VdP. It is the second TdS equation. These equations can also be written for a unit mass. TdS small du is small dv. So for unit equation, TdS equals du plus pdv is the first TdS equation. TdS equals dH minus vdp is the second TdS equation. It is very important two equations. The third, entropy change in irreversible processes. The last page, we just discussed the reversible process, the entropy change. Here, we'll discuss the entropy change in irreversible process. Why we use the entropy as the sign of irreversibility? Because we do some comparison, we can find comparing reversible processes with irreversible processes. We can find that there is difference. We can find if there is no heat transfer, the entropy change is zero in reversible process. Reversible process, if no heat transfer, no entropy change. However, in irreversible processes, the bigger entropy change, the more the irreversibility of the process. Irreversible process, the entropy change always is not zero. Entropy change in irreversible process, how to do some comparison? We can use the last several pages, use the Carnot cycle, reversible cycle, the Carnot theorem. We can do the same thing, same way to do some comparison. Just this PV diagram. If 1A2, 2B1, this cycle is not reversible cycle. If it is irreversible cycle, do the same thing as above. We use the many small mathematic lines, arithmetic lines to cut this cycle. We can obtain many small Carnot cycle. However, this small Carnot cycle is not reversible cycle. From the Carnot theorem, we obtained for every small cycle, its efficiency, here the efficiency is not reversible cycle efficiency. Because this cycle is not reversible, it is irreversible. So this is smaller than that of the reversible cycle. Reversible one, this small cycle is the efficiency becomes small. So the equals 1 minus dQL over dH for one small Carnot cycle. Certainly smaller than eta C. Eta C is the Carnot reversible Carnot cycle. Eta C equals 1 minus TL over TH. Certainly we easily obtain this equation. From this equation, we can obtain dQL over TL larger than dQH over TH. Notice, please, this equation, the QL, is rejecting the heat to the surroundings. It should be negative. Then this equation we can write become dQH over TH plus dQL over TL smaller than 0. Obtain another equation because QL originally QL is minus, is negative. From this equation, together all the small cycle we can obtain. From the irreversible process, we obtain integration from 1A2 integration delta Q over T plus integration from 2B1 dq over T together certainly smaller than 0. So for irreversible process, this equation together equation smaller than 0. If it is reversible process, just equals same 0, equals 0. Together, irreversible process and reversible process will obtain a very important equation. Just is a circle integration delta Q over T small or equals 0. This equation, we can call it inequality of Clausius. Very important. The equals sign symbol is for reversible process. The small sign symbol just is for irreversible process. Thank you.